So I'm going to talk to you today about a research project that is actually the one that brought me to Penn State. So I'm very thankful for the grant that made this possible. And also, one thing I like to do with my research projects is give them fun acronyms and things like that, because each project is unique. And we call this one the COMB project. And COMB has nothing to do with comb in your hive, but it's an acronym for Conventional and Organic Management of Bees. So basically, we all know that there's lots of stressors on honeybees. Lots of things outside of your control, like weather, and, temperatures, and the pesticides of farmers that you have never met, things like that. But there are things that you can control, of course, and that's your beekeeping and your management. So that's what I'm pretty passionate about studying, is what can I do to my bees to have the healthiest, most sustainable operation possible. And I just want to tell you about beekeeping in Pennsylvania. It's different than Manitoba, clearly, and we have mostly hobbyists. So like 98% of the beekeepers have just a few colonies, 50 or less, and they're just stationary honey producing colonies. There's like maybe 2 beekeepers that are crazy and bring their bees to almonds, but that's like very, very rare. And so as an extension educator, which is my current job, I am trying to teach every type of beekeeper how to have healthier bees that actually overwinter, because we're losing regularly 40% of the colonies overwinter. And the other thing about all these hobbyists is that they all are in, well, not all of them, I wish they were all, in a local club. So in Pennsylvania, we have 37 local clubs, and each one of them is made up of beekeepers in a small part of the state. And they get together and talk about beekeeping. And so what I found visiting these clubs is that there's lots of different types of beekeepers. We have the conventional beekeepers who are like, you have to use amitraz, treat, I don't even test, I just treat. Then you have sort of the more organic that are like, I don't really like synthetics and I don't like to use the chemicals if I don't have to. And then on the other side, treatment-free. Are there any treatment-free beekeepers, do you think, in Manitoba? Anyone in this room? Well, they have very strong opinions about all these 3 groups, think that they're doing what's best for bees. They have reasons in their mind that what they're doing is best. When they're treatment-free, they think that chemicals are going to hurt the bees, so they're not going to use chemicals. And the people using amitraz are like, well, you can't just get away with not using amitraz, etc. So I decided to show them the data, right? I like data, I need graphs, and replication, not just anecdotes. So we set out to do a long-term study with funding from USDA to do a side-by-side comparison of these 3 general philosophies toward beekeeping. And we acted like a honey producer having full-size colonies, because by the way, if you're chopping them up into nukes, you can probably be treatment-free because you're sending the mites off with every frame of brood, right? But in reality, when you have full-size honey-producing colonies, that's the real test for whether they're able to control mites on their own or not. And we acted like a sideliner, which to me is like a mid-size operation. We had almost 300 colonies in this study. And so just to define this more, I want to get these names in your head. So conventional beekeeper, to me, if we did a Venn diagram, would be a big circle where whatever's registered is okay to use, generally. So that's like your typical beekeeper that's like, what are my options? Well, all of the possible options are in your circle, right? You can use organic acids, thymol, and you can also use amitraz for mites. Then we get an inner circle from that, and that's organic. Now, organic is not chemical-free, it's just restricted. So for us in the US, for organic certification, you can use formic acid, oxalic acid, and thymol. They're all organic treatments. And then getting more restrictive, we have our chemical-free or treatment-free options where they never put a chemical into the hive. Okay, so these are the three things I'm going to talk about over and over and over for this whole talk. And they're a bit color-coded. So every time you see blue, it's conventional, green is organic, and red or purple is going to be chemical-free. And I actually just had an email the other day from someone objecting to the name chemical-free. But believe me, we had like a million conversations about whether that should be called chemical-free or treatment-free. And even within chemical-free, there's like a whole spectrum of types of people, and they don't agree on anything. So just suffice it to say, if we think about these, what we call management systems that I'm going to discuss, the ones that never got chemicals are chemical-free, so it just made sense for us to call it that. I don't like to be some like professor in my office thinking that I understand beekeeping in Pennsylvania. I like to ask my beekeepers. So before we even started, the fall before we were about to set out on this big project, we brought in 30 of the top beekeepers in Pennsylvania, and we made sure that we had representatives that are currently doing conventional beekeeping, organic beekeeping, and chemical-free. And I don't want to forget to tell you that I'm talking about organic and organic certification, but nowhere in the US can you get certified because of the land use. So remember, I'm only talking about management and what you're putting into your hives. I can't speak to the land around that with this project. So we brought these people all together into a room just like this, and we fed them and we said, okay, get into groups and help us write our protocols. So they had lists of questions about the equipment they were going to use, which treatments were we going to use and when, screen bottom board versus solid, all of those things. And so even though they may have disagreed, they had to talk it through until they picked the thing that we were going to do. So we called these our stakeholders, and whenever somebody complained about our choice, well, why'd you use a screen bottom board? I got to say, because the stakeholders told me to. So yeah, they were a great group. And then throughout the 3 years of this project, we would meet with them regularly and like give them the data first. They were very excited to know how things were going. And we would meet again just to like tweak things, and we would often email them and bring them in. So they had a real stakes into this project and felt a bit of ownership. And then they could also speak about the project very intelligently because they were in from the ground. So I don't want to spend, I told them I needed an hour and I only got half an hour because I usually spend a long time really describing these management systems so you can really get it in your head. But let's just very simply talk about this. So on your left side here, we have conventional, and in terms of equipment, they had standard comb, which was worker throughout, a screen bottom board, and also we used a queen excluder. And the inner cover that we used is a wintering cover. Do you guys use those at all? It's like a normal wooden inner cover, but it's got a shim built in. Anyway, so that's what we used for equipment. For organic, again, standard equipment, standard comb, except for we were doing drone brood removal. So in the brood chamber, one frame of drone brood was in each brood box. We used a solid bottom board and a wintering cover and no queen excluder. And then for chemical-free, they like everything to be as natural as possible. And one of those things is the comb size. So standard comb that you're buying is about 5.4 millimeter hexagons, but in nature, the bees, feral colonies will build smaller cells. So you can buy this specialty comb that's called small cell, that's 4.9 millimeters. By the way, if you do a research review on whether that helps with the varroa or does not, it's like split. The different projects say, yes, no, we're the definitive. So I don't know if it helped with varroa, but our stakeholders wanted that. A solid bottom board. And for them, they understand that in a natural colony, bees will build about 10% drone comb. So they felt wrong giving them all worker comb. And so when we were creating these 4.9 comb plastic foundation in a wooden frame, we just cut the foundation short so they had an inch on each side, which was about 10% of a frame, where they could build whatever they wanted. And by and large, they did choose to put drone comb in those open spaces. And we left it like that's what they wanted, that's what they got. And we also encouraged a propolis envelope. So there's lots of work that's showing that propolis is medicinal and the bees will collect it. And in a feral colony, they're going to be like coating the entire inside of that cavity. And so not only did we scratch up the insides of all the brand new boxes so that they would want to fill it with propolis, but the inner cover was actually cloth. So we used this stuff called cotton duck, and you just lay it on the top bars, and they totally propolized it. So by the end, it was like stiff. You could hold it up. So they were really encouraged to bring in propolis. They thought, our stakeholders thought that would help them to stay healthy. Okay, so that's the equipment. And then as far as treatments go, the first year we put packaged bees on brand new equipment. So they had to build out the comb, and they were like brand new baby colonies. And so as you know, in that situation, the varroa mites don't really build up that first season. So for the most part, even though we monitored the mites and would have reacted if mites got too high, we didn't need to. But in the fall, we did a blanket treatment. So in general, we decided that if an individual colony got above a 1% threshold, we would treat all the colonies in that apiary that were in that treatment group. And however, in the fall, everybody got a treatment. It was like, I don't care what your mite numbers are, everybody gets a fall treatment. So for conventional in the fall, everyone got amitraz in this form of Apivar 4 strips. For organic, everybody got Formic Pro 2 strips, and then of course no chemicals. Okay, then the next year after we had overwintered mature colonies with mites building up, and in future years, we had to be more strategic with our program. And so we really are interested in integrated pest management and rotating chemicals. So we had a general plan where early in the season, so May, June, if mites got over threshold, we would use oxalic acid. If later in the season they got over threshold, we would use formic acid. And then in the fall, conventional would always get amitraz. For organic, if they had gotten formic acid already, they got Thymol. And if they hadn't had formic acid, they got formic acid. Formic acid is my favorite. There's so many reasons why formic acid is awesome, but mainly killing the mites under the cappings is like a really awesome benefit. There's no other product that can do that. Okay, so hopefully you have that all memorized. And so here's a map showing you where we are. So this is my home state of Pennsylvania. Each star is a farm. Oh, and look, there's West Virginia on there. So we got a call from someone in West Virginia. There's this place called the Appalachian Beekeeping Collective where they teach out-of-work coal miners how to be beekeepers. It's a really awesome program, and they buy the honey back off of them so they're guaranteed an income and things like that. Well, they were setting up 1,000 new colonies, and the person that they had hired was supposed to do research. So she's like, hey, Robyn and Margarita, how about if I do some replicates of what you're doing? I'll follow all your protocols, I'll use new equipment just like you, and you'll have an additional set of samples. So we were like, yes, please, that sounds awesome. So there were 2 farms in West Virginia, 2 in central PA, 2 in southeastern PA, 2 in northeastern PA. And at each of those farms, we had 3 apiaries, so 1, 2, 3, that were at least 100 meters apart, some were much farther. And then within an apiary, we literally ran these management systems side by side. So in an apiary, you would have 12 colonies, 4 would be conventional, 4 organic, 4 chemical-free, at least the first year. And then the order of those varied, so that's why you see the colors being different, because we didn't want the drifting to always be affecting one treatment or another. So in a region, I didn't do it. In a region, so a set of 2 farms would have every left, middle, right possible combination. So that worked out pretty well. Okay, so as I said, these started as package bees. This is what normal packages look like, not those weird tubes that we saw. we got our packages from Georgia, as Pennsylvanians do, and in there is a feeder can and a mated queen. We never bought bees again after that for the project. We did not like, however, that these was pretty much unselected stock. So we were thinking when people see these results, they're going to be like, of course all the chemical-free colonies died because you just took Georgia packages that are used to being treated and didn't treat them. So what we did, our next best choice, because funding cycles don't really work. They don't really think about bees when they think about when they're going to tell you got the money, right? If we wanted to have some excellent stock that was known mite resistant in the form of packages times 300 for the spring of 2018, we would have needed to know a full year season ahead to warn someone to build up just for us. And we couldn't do that because we were just starting to do this planning in the fall of 2017 and we needed them for spring. So our next best option was to get the best queens we possibly could and requeen all of these colonies to get those packages, get them building comb and building up, and then put in the good genetics. So this queen producer, Devin, is in northern Pennsylvania, and he had a colony that had swarmed and lived in the part of somebody's house for 4 years, completely unmanaged. He did a cutout, and they were completely treatment-free for 3 additional years. And then he made us sister queens from that colony. So unfortunately, we didn't test that to know what mite resistance traits they might have, but it was pretty clear that they had something. And again, this was the best we could do. You can't do those tests in the middle of winter when you're planning on who to buy queens from. So we got sister queens that were open mated from Devin so that anything that we saw, we wanted it to be due to our management, not some kind of genetic difference or something like that. Every month from April to October, each of the 3 years of the study, we would do an alcohol wash. And then every fall, right before the bees were considered to be wintering, we would take a snapshot of the colony. So we would do an alcohol wash, which was after fall treatment, just to make sure they were low going into winter, or not low in the case of no treatment. We would take a sample for nosema on alcohol, and we would take a sample on dry ice for lab testing of vitellogenin levels, gene expression, and viruses. So it was this really nice snapshot of the health of the colony going into the winter. Of course, we were acting like a sideliner honey producer, so we took really great care to figure out how much honey each colony made. Can you imagine labeling every box and every frame and having to weigh before and after during your extraction process? People weren't too pleased with me, but they did it anyway. And of course, overwintering success is critical. So any bees that were alive in October and then also alive in April were considered to have survived. We didn't do any fancy, like they were either alive or dead. There was no they don't know they're dead yet kind of thing. It's like they're alive or dead. Okay, so most of my graphs look very similar to this, where you're going to see 3 bars. Across the bottom is management system. So we have our orange is our chemical-free, the blue is conventional, and green is organic. And in this case, we're looking at honey production. And the letters above those bars are telling you what's different and what's the same in our statistical tests. So this pattern is ABB, which means that the chemical-free honey production was significantly different than both conventional and organic and conventional are not different from each other. Does that make sense? Okay. So in terms of honey production, over the 3 years, conventional and organic made much more honey than the untreated colonies. So I was taught not to show raw data, but I do like showing detailed data, even though most of my slides, except for this one, are very summarized and crunched together. I just wanted you to see what happened to the varroa mites over these 3 years. So this is our monthly varroa alcohol washes throughout the study, and then averaged over all the colonies. So you can see that mite levels stay pretty low early in the season, and then it's late in the season when they peak. Of course, everyone's seen this for yourselves, right? And so the first year, those chemical-free colonies, which never got a treatment, only got up to about a 4% infestation. So that when they went into winter, I'm like, that's not so bad, 4%. It's not, I mean, it's above the threshold, but not crazy. And then each year you can see it's, lower early, and then when we treat, it goes down, or if we don't treat, it goes up. So these chemical-free colonies in their second year got quite high, third year, same thing. So that's the general trend of what Varroa did over the seasons, but we're really interested in that snapshot. My thing's not working now. We want to just see that fall snapshot. That's really what tells us everything. Can you just advance, please? There we go. So just looking at October Varroa wash levels, you can see, again, the ABB pattern. So Varroa mites were very, very much higher in the chemical-free colonies, but using either organic or conventional, we were very well able to keep mites down, okay? No, it's working now.
It's working now?
Thank you. I heard the computer do something, and that was, yeah. So what did this mean? So mites were not controlled in the chemical-free colonies. And I'm sure you've been taught that the only way to control viruses is to control the mites. And so this is what happened to the mites. And unfortunately, at the time, when we decided what to test, we didn't really understand that there's different strains of deformed wing virus. You might have heard there's like DWVA and DWVB. So we just did a DWV complex. So we can't tell you anything about the strains, but deformed wing virus was significantly higher in those colonies with higher mite loads. That's not a real surprise. But again, conventional and organic treatments kept viruses low. Nosema was kind of weird. We didn't do any actual treatments for nosema. We never fed Fumidil or anything like that. But there did seem to be some differences, maybe having to do with stress of the mites or something like that. I'm not really sure why this happened, but you can see this is pretty much the only graph you're going to see that's not ABB. This one's ABB. And what that means is that the conventional system didn't have a different amount of nosema than chemical-free or from organic. But organic was definitely better than no treatments at all. Vitellogenin is something that we actually didn't expect to differ between the colonies because it's sort of, one of the things that it's looking at is their nutritional level going into winter. And so since they were side by side, all with the same access to the same food, this is what we expected. No difference in vitellogenin levels going into winter. Then we get into some immune system measurements. So I am not the lab person or an expert on these genes or gene expression, but I do know that a higher level is bad for bees. And to me, I like to describe it as like their immune system is activated. I don't want my immune system to be active. I want it to be calm and doing nothing, right? So in this case, we're looking at something called defensin 1. And honeybee immune systems are a little bit different than ours, but they do have like distinct immune pathways that are responding to distinct things. And so the different things that we measured are different immune pathways. So the whatever immune pathway, I don't know the name of it, includes defensin 1, was active more when the mites were not kept under control with any chemicals. Another immune pathway where you can measure hymenoptacin, same thing. So without taking care of the mites, you're having this other immune pathway also activated more. And naked cuticle gene is another one. Do you feel like I'm just showing you the same graph over and over? Yeah, me too. What about colony survival? So remember I told you that we bought packages and we never bought bees again. I'll admit to you that we did make splits to make up for those dead outs, but they were no longer part of the study. So what you're seeing here is just continuous colonies that began in 2018 and made it all the way through to 2021, spring. So I wanted the colony density to stay the same at 12, but we were only following individual colonies. And so on the right, you can see how winter went horribly for those chemical-free colonies. But for the other two management systems, and by the way, I do have the detailed data that's in the slides after my thank yous. If you really want to see each year parsed out, I can show you that. But you can see that survival without any chemical controls was horrible, horrible. The first year, with only 4% mites, we only had 37% of the colonies survive. And then going on, then we only had 25% survive, and so on. So while we started with 96 in that treatment group, how many do you think were left in 2021 spring? 1. So it was heartbreaking as a researcher to have to watch those bees suffer, but we felt that for science, we had to do it. We did also have some summer losses, so that's why I'm including the graph on the left. It kind of has winter, summer, winter, summer. And I just have to admit that it was a failure to requeen that would kill a colony in summer. I didn't really see anything else cause that demise. But we didn't buy queens to put in when they swarmed or we did a split. They had to requeen themselves. And so that we only had about 65% success of that queen returning mated to continue that colony on. So that's what was, if I could redo the protocol, I'd be like, we probably shouldn't do those walkaway splits, right? We should give them queens or something. Yeah. Okay, I think I talked really fast and I'm keeping you guys in time, but I'm gonna just end with this summary. So this is a crazy summary slide that somebody made for me and I'm like, whoa, what in the world is that? But this is just to get you thinking about what are your bees going into winter looking like on a health basis. So it was clear that everything was ABB, right? So the BBs are organic and conventional management, so we lumped them together. So if you have a colony and you're using an organic or conventional management system as compared to a treatment-free system, overall, this arrow here is saying that that's a positive thing for survival. So I know it's positive because it's orange, because this dark red is negative. And the thickness of that arrow is telling you how strong that relationship is. So being in one of these systems is a positive. We don't want bees to be in a treatment-free system, so do not recommend. And then if you look at each of the individual pieces of that, what you can see is being in this management system was a negative for varroa mites. Okay, we're killing mites. It was a negative for nosema, which is, by the way, called Viremorpha cerani now, so that's why there's a V. It was, being in these systems was bad for viruses, bad for having your immune system excited, etc. So those are all good things, right? The things that we were doing as beekeepers, our management was harming things that harm bees. If you want to look at the right side, what you're looking at is, what does it mean if you have more varroa, you have less survival, more nosema, less survival, more viruses, less survival, more higher active immune system, less survival, etc. So that's basically just a summary of that whole entire project. So if I were doing this again, I would 100% start with some more excellent stock like Corey is developing, or like maybe some of you are developing some more mite-resistant stock. Even though we got the best queens we could in 2018, clearly not good enough. They were not keeping mites under control. So may that be a lesson to you, that if you think that you have mite-resistant stock, please keep monitoring anyway. They might not be as resistant as you thought. So I think as a beekeeper, it's your responsibility to control mites if your bees cannot do it themselves. Also, it became clear, as we know, that controlling the mites really did keep viruses down and kept the bees healthier and surviving the winter. So your management decisions have a great impact on everything, and I'm sure you know that. The other thing I want people to notice is the organic system, so using oxalic acid, thymol, was absolutely good enough to control mites. So if anyone ever says you have to use amitraz, say, no, I don't. And by the way, they're resistant in the prairies anyway, so why would I, right? And so I use this in Pennsylvania in hopes of catching some newer beekeepers that aren't set in their ways, thinking things like I have to use amitraz, and then they don't want to contaminate their wax either, which amitraz does. And I also tell them that you can use this. We don't have a beautiful co-op where we all take our honey. We have to individually market it. And so you could say, you can't say you're certified organic, but you can say, I use only organic management in my colonies, right? Especially if you're at a farmer's market or something and you get to talk to your customer. So I don't like amitraz. I never want to use it again. I had to use it for this project, and then I tried to sell off all those combs that were exposed to it, and now I only use this organic management system. So I just want to thank the army of people that were involved. I love to involve local beekeepers in my work. They like coming out and being part of the research, so I have some great volunteers and some paid people. And then, of course, there were all those different sites, so we had local people that would be able to help us at each one. Okay, any questions? I'll wait for the microphone person.
Thanks, microphone person. So my question is around the term organic. Do you think, that term itself could act as a double-edged sword? So on one hand, you have people that are more likely to gravitate towards it, like, I like that, I like what it implies. And then on the other hand, you can get beekeepers, particularly maybe some commercial beekeepers that might misunderstand what that could include. Like they're thinking that, that they could take that as no treatment. So I think for these terms, and it's really, what do you think about that as far as like a way to communicate this to beekeepers in a way that they can catch on to like what they need to do?
Yeah, this is absolutely a time to educate people about what organic means, because you're absolutely right. When people saw the title of our paper, by the way, this is published and you can have free access to the paper and the figures. People thought we meant chemical-free was organic, right? And we're like, no, do you think that your organic fruits and vegetables don't get anything sprayed on them ever? Because you're wrong, right? So it's an education point. Lots of commercial beekeepers roll their eyes like we can never be organic, right? So I get that. But I think as a sideliner, honey producer, it can be done. And then maybe that person can get a bit more money for their honey and have really great success. I mean, when we were having only 15% losses, the state average was 40 and 50%. So if at least a hobbyist comes in, it's funny, when I joined Extension, I was told, you're not supposed to tell them what to do. You're supposed to just give them all of their options. Well, every person wants me to tell them what to do. Yeah. Right? Just tell me what to do in spring and summer and fall and I'll do it. So I did publish what we call a fact sheet in Extension that is all of the details of this organic management system. It's a 4-page document, like 2 pages, double spaced. And I was like, okay, I'm not going to tell you what to do, but I can tell you what we did and that you can see the data associated with it. And maybe you want to try it for a couple of years. And if you have good wintering, then you can tweak it. Like maybe you absolutely hate that drone brood removal piece. I actually removed that from myself because it was just too much to keep up with, right? Because you can't be gone for more than 24 days or you're growing mites, So I think the proof is in them trying it for themselves and understanding that, organic does not mean chemical-free. That's critical,
You partly answered my question, which was going to be, did you change any minds?
I do believe I did. Probably from treatment-free into organic rather than away from amitraz, because people are just used to doing their thing, right? Some people realized they were doing organic management and didn't know it. And so I think I helped them to, have a better mindset with what they're doing and market to their customers. But actually that beekeeper that sold us those queens was treatment-free. And I hired him to help us, manage the colonies, and he just saw the light. Because I totally think you can be treatment-free, or should be, as a breeder, right? You need to see what the bees can do. But you don't just let those colonies that are overrun with mites die and suffer and get PMS. You do something about it. You monitor, because of course you're making selections, and you cull those colonies that aren't, keeping mites under control. So he saw that, and I was like, you don't have to treat every colony. You don't have to treat colonies that aren't over threshold. But you have to be aware of what's happening and treat if you need to. So at least I think I got people doing that.
My question is maybe not a fair question, but what really intrigued me, one of the things that really intrigued me in your talk, and I would love to learn from you, is why you're in love with formic acid. Because honestly, I want to fall in love with it too. So I don't know if that's a fair question.
No, that's a great question. I love that question. Number one, killing mites under the cappings. I don't know if the non-apiaries person is in here, but I've had many discussions with Tom Nolan. I see you back there. I've had many discussions with Tom Nolan about, so in the US, we don't get to do flash treatment. That would be off-label. We have to use Mite Away Quick Strips or Formic Pro. So we have to purchase that product to use it. And there's two ways to use it, one pad for 10 days and a second pad, or two at once. And it is, I wish I had the data to prove it to you, but it is pretty clear that you have to have two pads to kill mites under the cappings. If you do one and one, you're just doing a long-term treatment, you're just killing mites on adult bees. So I love it when you use two pads and you kill the mites under the capping. It's like a whammy, right? I love that you can use it with Superzon, which we can. And the best part about it is that you will never unknowingly touch that product and hurt yourself, because the minute you go near it, you're like, whoa. Yeah. So it's like you protect yourselves. If you're using Apivar, you could have no gloves on and do your thing and get cancer 10 years later. I'm not saying it causes cancer. I don't really know. But like your skin would start to feel like rubber. Right? So I just love that about it. It's like you protect yourself because it's so obviously horrible. So that's what I love about it.